Welcome to another. welcome to another. Sorry, you'll have to forgive my voice today. I'm a little hoarse. All right, so we've finished our discussion on basic probability. And now we want to move on into a little more depth into probability. But let's consider an example that we've kind of considered already. And that's flipping a fair coin 3 times. And of the things that we've talked about so far, we've talked about how we can assign each one of those flips a letter. We can say, let's let H be equal to heads, and let T be equal to flipping and getting tails. Right? And we've talked about the sample space for these types of experiments. So let's say the sample space, let's say what that is. The sample space for flipping a coin 3 times is heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So previously, we've kind of talked about how these kind of experiments fall under the category of equally likely events. And so we've got 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So the probability of each one of these, we would assign the probability of 1 in 8. And so far, that's how we've addressed these probability scenarios. By just asking, well, let's make events that include some of these outcomes, and then we can define the probability of that event by just looking at how many outcomes there are and multiplying 1/8 by that number. But what if we wanted to look at something else about this? And to do that, we're going to define what's called a random variable. Now, a random variable is just going to be a function that takes some type of outcome from our sample space and assigns it a number. And so in this case, we're going to let x be the random variable of, or let x be the number of heads we get. And so the reason that I have x drawn like this is because generally in probability, random variables get a capital letter, and the outcome of those random variables get a lowercase letter. So the random variable x would be discussed using the capital value of x, and the value of capital X would be little x. So in this case, we have a random variable x that is the number of heads that we get after flipping a fair coin 3 times. So the possible outcomes of x, so the sample space of our value x, is instead of these 8 things, the possible outcomes for x are we can get 0 heads, 1 heads, 2 heads, or 3 heads. That is a terrible 3. And so these are the outcomes. This is the sample space for this random variable x. And it's based on the same experiment of flipping a coin 3 times as this original sample space. And we said that this sample space had 8 outcomes in it, and each of those outcomes is equally likely. So we can define the probability of each of these as 1 in 8. So the question is, are these outcomes equally likely? And so we can investigate this. We can ask which of these outcomes in this original sample space are going to give us an outcome of x of 0. And so we can do that by saying if x is the number of heads that we get, then for each one of these outcomes, we can say what x would be. So if we were to flip a coin 3 times and we get heads, 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 then we would report the number of heads that we got, which in this case would be a 3. And heads, heads, tails would give us a 2. And heads, tails, heads would give us a 2. And heads, tails, tails would give us a 1. And tails, heads, heads would give us a 2. And tails, heads, tails would give us a 1. And tails, tails, heads would give us a 1. And tails, tails, tails would give us a 0. And so we can look at this, and just like with any other event, right, we say, well, what's the probability of us getting an outcome of 0? Well, the only outcome that's going to be in that event is tails, tails, tails. And we know that has probability of 1/8. So the probability of getting 0 is going to be 1 in 8. So what's the probability of getting 1? Well, if we talk about the event of x being equal to 1, then the outcomes that come out of that are going to be heads, tails, tails, or tails, heads, tails, or tails, tails, heads. But each of those has a probability of 1/8. So that means the probability of getting a 1 actually happens 3/8 of the time. So already we know that these are not equally likely events because the probability of getting a 0 for x and a 1 for x are different. So let's write down what we have so far. So for our random variable x being equal to some value little x, right? Remember the value is going to be little x. We want to talk about what's the probability of the random variable being equal to that. So we said the different values that the random variable could take are 0, 1, 2, or 3. And we already said that 0, the only way that can happen is with tails, 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 so that's 1 in 8. And we said that the way that 1 could happen is this outcome, this one, or this one. So that's 3 in 8. And if x is going to be equal to 2, then that can happen for heads, heads, tails, or heads, tails, heads, or tails, heads, heads. So again, we have 3 different outcomes that satisfy this, and they all have probability of 1/8. So again, the probability of getting x equals to 2 is 3 in 8. And lastly, what's the probability that our random variable x is equal to 3? And that would mean we get 3 heads, and the probability of getting 3 heads is going to be just when we get heads, 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 and that's 1/8. This table that assigns these different probabilities to the outcomes of this random variable is what we call a probability distribution function. Because that's what it does. It distributes the probability of events happening over the outcomes of this random variable. And so any arrangement of these probabilities to the outcomes of a random variable can be a probability distribution function, or a PDF, as long as it meets 2 criteria. The first is that each of the probabilities assigned to these outcomes has to be between 0 and 1. It makes no sense to talk about probabilities that are negative. We don't discuss what that means. It also makes no sense to talk about probabilities that are greater than 1. We can't talk about what it means for the probability of getting 1 heads to be 110%. So 1, we have to have probabilities that are between 0 and 1. The second requirement is all of the probabilities that we assign to these outcomes, when we add those together, it has to equal exactly 1. So if we look at the probabilities assigned here, we have 1/8 plus 3/8 plus 3/8 plus 1/8. And that gives us 8/8 or 1. Now we're going to continue to talk about these probability distribution functions in class. we're going to work on some examples for how we can take different original experiments, define some random variables, and come up with their probability distribution function, or their PDF.